We next have Mr. WSP Fernando from, once again, the KDU. He's a lecturer in mechanical engineering. Mr. WSP Fernando, he will present on an ARIMA, I do not know, a modeling approach for forecasting exchange rate. Fernando.
Okay, good afternoon everyone. Today my presentation is an ARIMA modeling approach for forecasting exchange rate. So the goal of this project is to model the exchange rate between the US dollar and the Sri Lankan rupees by using the ARIMA model. So this modeling of this exchange rate, we need a very accurate and a very sophisticated modeling technique to model this exchange rate, because from a macroeconomic point of view, the fluctuation of exchange rate heavily affect the economy of a country. So these are the then unemployment rate and etc. Some of the parameters. Then economic from the aspects of economic life, for example, the business planning, state and local budgeting, financial management, monetary and fiscal policy also need this prediction of this exchange rate parameters. To model this forecasting, basically the statistical approaches plays a significant role. Broadly speaking, the statistical approaches we use for economic forecasting fall into two categories: the time series method, then second, the structural economic models. So before I move on to the time series, I would like to give you a briefing on what is the time series. So time series is a collection of data that has been taken in regular intervals. For example, the monthly tourist arrivals from India to Sri Lanka, the quarterly GDP of Sri Lanka, hourly price of stocks and shares, then weekly quantity of beer sold in a pub. Then the time series and structural economic models. The time series method uses basically the economic fundamentals to guide the variables we need to model, and it is highly dependent on the past data patterns and tries to predict the future. In contrast, the structural economic models, which uses formal economic theories and attempt to translate those theories into empirical relations. For example, the demand functions, supply functions, the Cobb-Douglas theory, all the formal economic theories are used. Then the advantages of this time series method. Now, in practical, these time series models use very small set of variables, while the structural models, they are heavily dependent on the these theoretical things in economics. So there have been a very large simultaneous equation systems which incorporate maybe hundreds of variables. So our results basically based on this special type of time series, the autoregressive integrated moving average, or concisely ARIMA model, which used to model non-stationary time series. This method is a very statistically sound method and used to extrapolate the values. Now this ARIMA model is comprised basically of two parts: the integrated part, which tells us from the I part, and the ARMA. And ARMA also can be categorized into AR and MA, the autoregressive and moving average. Autoregressive part, which models the data part or the real value part, and MA, moving average, which models the future error based on the previous errors. And this RIMA model can be represented mathematically by RIMA BDQ. BDQ are the parameters, and this 5PB represent the AR model. Then nabla D is the difference or the integrated part. Then theta QB is the moving average part. Then this, as I told you earlier, this ARIMA model can use to model non-stationary time series data. So what we actually do is, now suppose there is a trend or increase in the data or decrease. So this increase and decrease may be linear or may be quadratic likewise. So if you have a function, a linear function, if you differentiate, then we get a constant. If you have a second order one, if you take the second derivative, it is a constant. So this Box-Jenkins approach, it tries to model only stationary time series data. Now, what we do is, initially we have a non-stationary one. Then by using the integrate part or the difference part, we convert that to a stationary time series. And this stationary time series can be modeled by the Box-Jenkins approach. This stationary time series means it is a constant mean, constant variance, and the autocovariance or autocorrelation is depend on the lag, only based on the lag. So this approach, there are several advantages and disadvantages. So the advantages are that it's built on a very solid mathematical statistics foundations, and it is very easy to evaluate the best model. The disadvantages are we need a large amount of data, and it is hard to explain the results we get to these unsophisticated users, means people who are not familiar with those things. Then estimation and selection will be by practice. So you need some practice to identify what are the parameters to use. There are no any concrete mathematical method to evaluate those parameters. Now, this exchange data, now I have taken this data from the period 2009 May to 2012 June 12th, and this is how the exchange the Sri Lankan rupee with respect to US dollar changes. And this data source I have given here.
Excuse me, what is this horizontal axis index?
Sorry? That index, it should be the, now when plotting the data, now those values 2009 May,
so like that.
it just use a index, integer value to identify the date.
Related to time.
Yes.
Related to time.
Then now if we analyze this data, now from our previous graph, we can see there is a positive trend of the exchange value. Then if we plot the our value, and if we analyze the correlation between our present value and the previous value, there is a strong positive correlation or autocorrelation between the values. So it is hard, or it is impossible to use the Box-Jenkins method. So, so we can we can also see this from the autocorrelation function, where we have a very strong autocorrelation, positive autocorrelation here. Right? And it has the autocorrelation values, they are decreasing very slowly, so it indicates a positive trend in the our original data. So those are the indications. Earlier, these are the visual indicators, and this is the analytical indication. So if we take the difference part, as I told you, there is an integrated part. So if we take the difference between the present value and the previous value, our difference value changes in this way. Now this tells us basically there is a constant value of the difference value is a constant. But there are few fluctuations. Other than that, there is a common. The average value is a common value, varies around 0. So this is what we model using the ARMA model or the Box-Jenkins approach. If we use the scatter plot, then we have a very approximate no autocorrelation variation. So we have tested with several models, the RIMA 110. Here we don't model the error term, it's only the parameter value, and we have the p value is 0, so we have a significant value, and the error term we have a 0.010. And if we take the autocorrelation function, all the autocorrelation values for different lag values are vary between the 95% confidence interval. So, and there is few values that goes beyond that. So there is a small misfit for the model. So again, I tried the 210 model, and we have a bit less error term, and the AR2 model also a very significant model. Then AR111, then we introduce the error term. Earlier it is 0. Now we use the 1. That is the error term we use, and we have the error term is much less. So this is the best model I got, right? The 121 model, and it has the minimum error term, and we have 2 regular differences. And this is the autocorrelation function for the RIMA 121 model. So you can see all the autocorrelation values for different lags vary between 95% confidence interval. So it indicates a better model. There can be other models, but for the models I checked, this is the best model I got. And these are for the conclusion. Now earlier I told you I got the data up to 2012 June 12th, and I predicted the values for 10 days, and now from the bottom, now June 13, June 14, now for the predicted value I got 132.6, and the real value was 132. Then for 5 value, now this method cannot be used for predicting for a large duration, but only for small duration it gives us a very good indication. So this is the end of the presentation.
Thank you very much, Shehan. You call yourself Shehan or Priyanka? Shehan. So Shehan is a graduate from University of Moratuwa. He has a degree he has specialized in computer science and engineering. Right now he's a lecturer in the mechanical engineering of KDU. His research interests seem to be not only on modeling, but computer vision, computer graphics, artificial intelligence, and so many other things related to that. And he also has plenty of publications. Thank you very much, Han.